Welcome to Learners Academy. So today we are going to talk about the differential equation. So if we will talk about CET, in CET they ask one problem every year based on differential equation. So this is important topic for CET exam. So we are going to talk about differential equation. So first we will see what are the prerequisites for differential equation. So prerequisites for differential equation is integration and differentiation. We should have the basic idea of how we integrate, how we differentiate. So we are expecting that you have the sufficient knowledge based on the integration and differentiation. So after that we will talk about the differential equation. So basically what is the definition of differential equation? So an equation containing dependent variable, independent variable and its various derivatives are called as differential equation. For example, suppose if I write y is equal to 3x plus 4. So this is differential equation? No, this is not a differential equation. This is simple algebraic equation where y is the dependent variable, x is independent variable, y is dependent on x. So we are saying that what is differential equation? A differential equation which contains dependent variable, independent variable and one derivative of dependent variable with respect to independent variable, that is called as differential equation. For example, if I will add here like plus dy upon dx. So this is called as differential equation because it is having one derivative of dependent variable with respect to independent variable. So now this equation is called as differential equation, the equation which contains dependent variable, independent variable and one derivative of at least one derivative. It can have one or more than one also. So one derivative, at least one derivative of dependent variable with respect to independent variable. So here if I will say y is dependent variable, y is called as dependent variable and x is called as independent variable. Okay, so the equation which contains one dependent variable, independent variable and at least one derivative of dependent variable with respect to independent variable is called as differential equation. Okay, so for example I can say like this: d square y upon dx square plus 3 dy upon dx plus y is equal to sin x. Now if I am asking, this is differential equation? Yes, this is also one differential equation. It contains dependent variable y, independent variable x and at least one derivative of dependent variable with respect to independent variable. This is called as differential equation. So simple definition of differential equation: a equation which contains dependent variable, independent variable and at least one derivative of dependent variable with respect to independent variable is called differential equation. Now after that we will talk about the type of differential equation, like how many type of differential equation we have. So differential equation is of two type. Differential equation is of two type. One is ordinary differential equation, second one is partial differential equation. Ordinary differential equation and partial differential equation. Okay, ordinary differential equation, if we will see what is ordinary differential equation, so we can see what is ordinary differential equation: a differential equation involving the derivative with respect to only one independent derivative, that is called as ordinary differential equation. Partial differential equation and equation containing derivative with respect to more than one independent variable, that is called as partial differential equation. For example, I can say, like suppose if I am writing dy upon dx, or I can write down d square y upon dx square is equal to sin x. For example, I am writing like this. So this is called as ordinary differential equation. Why ordinary differential equation? Because this differential equation contains derivative with respect to only one independent variable x. So that's why this is called as ordinary differential equation. Now we will talk about the partial differential equation. Partial differential equation means the differential equation which contains derivative with respect to one or more than one independent variable, that is called as partial differential equation. For example, if I will say like del square phi upon del x square plus del square phi upon del y square plus del square phi upon del z square is equal to, we have some function of x, y, z. It can be any function x, y, z. It can be homogeneous function, it can be 0 also, so it can be any function. So if we will see this differential equation, it contains derivative with respect to x, y and z. So since this differential equation contains derivative with respect to more than one independent variable, that's why this is called as partial differential equation. And this differential equation contains derivative with respect to only one independent variable, that is called as ordinary differential equation. So I hope students this would be very simple for you. If I'm giving you any differential equation and I'm asking you that differential equation is ordinary and partial, then it is very simple. Okay, now I will write down I will take some example and we will see whether it is ordinary or partial. Okay, so now I'm writing some example and you have, like, we will see whether it is ordinary or whether it is partial. So for example, I'm writing d square y upon dx square plus y is equal to sine x, or I can take like sine square x. Now if I'm asking this is ordinary or partial, so we can easily say this is ordinary differential equation because it contains derivative with respect to one independent variable only. For example, now d cube y dx cube plus 2d square y upon dx square plus dy upon dx is equal to plus y xy is equal to 0. So this is also which differential equation? Ordinary differential equation. It has three derivative term, but we are not talking about the term, we are looking for which it is having derivative with respect to which independent variable. So this derivative also having with respect to x, this is also with respect to x, this is also with respect to x. So since it is having derivative with respect to only one independent variable, that's why this equation is also called as ordinary differential equation. Now for partial, basically it should have dependent derivative terms with respect to more than one independent variable. Like I can write down del phi upon del x is equal to c del phi upon del t. So if I'm asking this is the derivative, this is the differential equation of which type? So this is partial differential equation. Why? Because it is having one derivative with respect to x and it is having another derivative with respect to t. That's why we can say this is partial differential equation. Okay, I hope it should be clear for all of you, like which is partial differential equation, which is ordinary differential equation. Okay, so we have the definition: ordinary differential equation, partial differential equation, like a differential equation involving derivative with respect to only one independent variable is called ordinary differential equation, and a differential equation involving derivative with respect to more than one independent variable is called partial differential equation. Okay, so now next topic that is very important from the exam point of view, like CET, sometimes you will see they are asking like simply what is the order and what is the degree of differential equation. So now I'm going to talk about degree and order of differential equation. Okay, so we will start with the order of differential equation. So what is the order? Order is very simple. If you will see on the screen, what is order? Order of differential equation is the order of highest order derivative occurring in the differential equation. Simply, it is the order of highest order derivative which is present in the differential equation, that is called as order of differential equation. For example, if I will say, like, for example, I am saying d cube y upon dx cube plus y is equal to sine x multiplied by cos x. Now, if I'm asking, first just tell me what type of differential equation? Simply I can say ordinary differential equation. Why? Because it is having only one derivative with respect to x. Okay, so we can say since it is having derivative with respect to only one independent variable, so we can say this is like ordinary differential equation. Now we have to talk about the order. So what is order? Order is simply highest order of highest order derivative. So highest order derivative is third order derivative. So simply I can say order of this differential equation is 3. Order of this differential equation is 3 because it is having one derivative with respect to it is having highest derivative of the order of 3, so that's why order of this differential equation is 3. Okay, so now another example, if I will see, we have d cube y and dx cube plus d square y upon dx square plus 2 dy upon dx is equal to 0. I have written this differential equation. Now I am asking what is the difference, what is the order of this differential equation? So what is the highest order derivative? Highest order derivative is 3. So we can say the order of this differential equation is 3. Okay. Now if I am saying to you, just can you please tell me what is the order now? So order of this differential equation is 2, because highest order derivative is 2, second order. So we can say order of this differential equation is 2. Okay. Now suppose I am writing the same differential equation in this way. Okay, I hope everyone will be able to find out what is the order, because highest order derivative is fourth order derivative. So we can say order of this differential equation is 4. So I hope this is very simple to find out the order of differential equation. What we have to find out, we have to simply find out what is the highest order derivative present in the differential equation. Okay, so in this differential equation highest derivative is 3. So we can say order of this differential equation is 3. In this differential equation highest order derivative is 4. So we can say order of this differential equation is 4. Okay, so now this is all about the order of differential equation. We have the example also which they have asked in the previous year CET. So we will talk about those problems also, but before that we will complete the degree also. Okay, because sometimes they can ask you order only, and sometimes they can ask you order plus degree both. Like they will ask you have to tell order as well as you have to tell degree. Okay, so we will complete the degree and then we will talk about the previous year CET problem and IIT problem also. Okay, so now we will talk about the degree. Okay, so now if you will see on the screen, what is the degree? Degree of the differential equation is defined only if it is a polynomial equation in its derivative. So students, first you have to see the meaning of first line only. So we are not talking about degree, what is the definition of degree. First we will see when it is defined. So we are saying that degree of differential equation is defined only if it is a polynomial equation in its derivative. Okay, so now first, there, if you will see, we have one term here which is polynomial. So first you should aware what is the polynomial. Okay, I hope you have studied already what is the polynomial. So you should know what is the polynomial, because it is very important to if we have to find out the degree of any differential equation, it is very important to find out the polynomial. What is the definition? Okay, I am telling you simple definition which is going to make the polynomial definition very simple. Like for example, suppose I am writing we have any function of fx is equal to x power alpha. If alpha is a whole number and finite number, what I am saying, alpha is a whole number and finite number. Okay, if alpha is a whole number and alpha is a finite number, then we can say this f of x, this function will be a polynomial, otherwise it won't be a polynomial. Okay, so now I'm just writing some function and you have to tell me which function is polynomial, which function is not polynomial. So I'm writing fx is equal to 1 plus x square plus 3x power 4 plus x power 5 dot 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 up to infinity. Okay, now second function I am writing fx is equal to 1. Now third function I am writing fx is equal to x power 4 plus x square plus 1. Next function I am writing fx is equal to x power 2 by 3 plus x power minus 1 by 3. And next function I am writing 1 plus x inverse. Now we have to find out of these 5 functions which is polynomial, which is not a polynomial. Okay, so one by one we will see. So I hope students, as per the definition, you can easily find out which function is polynomial, which function is not a polynomial. Okay, so first function, if you will see, this is polynomial or no? So this is not a polynomial. Why? Because if you will see, it is extending up to infinity. So infinity means the power of x is infinity, and what we have written, the power of x is alpha, where alpha is a whole number and it can be finite number. So here alpha is going to be infinite, that's why first is not a polynomial. Now second one, fx is equal to 1. So fx is equal to 1, can I write x power 0? x power 0. Now you should know what is the whole number. Whole number means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all are the whole number, but it should be finite. So x power 0, and we know that 0 is a whole number, it means this is a polynomial. Okay, now this is polynomial. Next one, if we will see what is the power of alpha, or what is the value of alpha. Alpha is 4, alpha is 2, alpha is 0. All we know that 4, 2 and 1 all are whole number. It means this is also a polynomial. Okay, now next one, x power 2 by 3, x power minus 1 by 3. We know that 2 by 3 is also not a whole number, minus 1 by 3 is also not a whole number. It means this is also not a polynomial. Now last one, I hope you would be able to tell me what is the this fx is equal to 1 plus x. If we will see 1, yes, x, then but when we will see x power minus 1, so alpha is equal to minus 1, and we know that minus 1 is not a whole number. If minus 1 is not a whole number, it means this is not a polynomial. So I hope it should be clear for all of you what is, how we are going to find out whether it is a polynomial or not. Simple definition, we have to find out the value of alpha. If alpha is a whole number and finite number, simply I can say this is a polynomial. Okay, so I hope this is going to help you. So first condition we have got, what is the degree? Like as of now we have not talked about the degree. We have not talked about the degree. Simply we have written when degree is defined. We are first we are finding the condition when degree is defined. So degree is defined if and only if the given differential equation is polynomial in its derivative term. Okay, if you will see here, it is written degree of a differential equation is defined only if it is a polynomial equation in its derivative. Okay, so when polynomial is a when differential equation is a polynomial in its derivative term, then only degree is defined. Okay, so now we will see when degree is defined, then how we will find out the degree. So if you will see degree, we have written here degree. So degree when defined, we have already write down when defined, then only we will find out the degree. When not defined, then we can say degree does not exist. When defined, how we are going to find out? Degree of a differential equation is the highest power of highest derivative term in it after differential equation has been made free from the fraction. Okay, so now we will see what is the meaning of degree of a differential equation. First I will make it clean, and then we will talk about the degree, and then how we can find out the degree. Okay, so what we are saying that degree if defined, so it is the highest power of highest order derivative term which is present in the differential equation when differential equation will be free from the fraction power. So we will talk about each and every term, what is the fraction power, when it will be free from the fraction power. I am going to talk about each and every term. So slowly we will start. So first we are clear, when degree is defined when it is a polynomial in its derivative term, then we can say degree is defined. Okay, so now I am taking the example. Now for example I am saying d square y upon dx square plus dy upon dx plus, this can be written as y is equal to x square. This is the differential equation we have. Okay, so now we have to check whether it is a polynomial, whether degree exists or not. So if we will see what we have written, what is the condition for degree existence? Degree existence condition is it should be polynomial in its derivative term. We have to check whether it is polynomial in its derivative term or not. So if we will see, it is polynomial in its derivative term, because here the power is 1, here the power is 1, here the power is 1. So if it is polynomial in its derivative term, it means degree exists. If degree exists, then what is the, how we can define the degree? How we can define the degree? Okay, there is one more thing. Suppose I am making this as a 3 by 4. And now if I am asking you degree exists or not? Yes, degree exists. Why? Because we are looking only for the we are only looking for the different. Okay. Okay, so we are looking here only for differential this degree of or polynomial in its derivative term. So polynomial in its derivative term, we are looking only for polynomial in its derivative term. That's why, so x power can be non whole number also, no problem. We are only for the whole number, we are only looking for the power of derivative term. So since power of derivative term is a whole number, so we can say this is a polynomial in its derivative term. Okay, now after that, if we will see, this is d square y upon dx square. Now what is the degree? Degree of differential equation is defined as highest power of highest derivative term. So what is the highest power? Highest power of highest derivative term. So first we will see what is the highest derivative term. This is the highest derivative term. So since this is highest derivative term, it means, and what is the power? Power of this differential equation is 1. So we can say what is the degree? Degree of this differential equation is 1. Okay. For now, suppose I am going to make it as a 3. Now if I am asking you, can you please tell me what is the degree? Degree still is 1, because we are only concerned with the highest power of highest derivative term. So here highest derivative term is 2. This is the highest derivative term, and what is the highest power? Highest power is 1. So we can say degree of this differential equation is 1. Okay. Now suppose I am adding one more term here, and I am saying that d square y upon dx square power 3. Now what is the degree? So now the degree is 3, because we are looking for highest power, highest order derivative term. So highest order derivative term is second order derivative, and second order derivative, if we will see what is the highest power, here the power of second order derivative is 1, here the power of here the power of second order derivative is 3. So what is the degree? Highest power of highest derivative term. It means degree of this differential equation is 3. Okay, I hope it should be clear. First, what is the condition for degree existent? Degree existence condition is it should be polynomial in its derivative term. We are looking only for the derivative term polynomial. Okay, so if this x power 3 by 4, we can say degree exists. Yes, degree exists, because we are looking for polynomial of derivative term. Okay. Second, if degree exists, then how we can define? So this is the highest power of highest derivative term. So highest power of highest derivative term is third power. So we can say degree is 3. Okay. Now if we will see, there is one more condition is written here, like differential equation has been made free from the fraction power. So we have to see what is the this fraction power. Okay. Now I will take one more example, then I will clarify what is the meaning of fraction power. Okay, for example, I am writing this as a d square y upon dx square. Okay, power like I am writing 2 by 3 plus dy upon dx power, like I can say this is 3 by 2 is equal to 0. Okay. Now, so now first we will see whether it is free from the fraction power, whether it is polynomial its derivative term. You will say, sir, it is not free from the or it is not polynomial in its derivative term, so so degree of this differential equation does not exist. Okay, but can we make it polynomial? Yes, we can make it polynomial. How we can make it polynomial? If we will see, this is d square y upon dx square 2 by 3 plus dy upon dx 3 by 2 is equal to 0. So how I can write down? This can be written as d square y upon dx square power 2 by 3 is equal to minus dy upon dx power 3 by 2. Now, can I take 6th power of both sides? 6th order power. So if I will take 6th order power of both sides, so what it will become? This will become d square y upon dx square power 4, and this will become dy upon dx power 9. Now students, if I am asking, can I say differential equation is polynomial in its derivative term? Yes, because here alpha is equal to power is 4, here power is 9. Both are whole number. It means this is polynomial in its derivative term. And now if we will see, is it free from the fraction power? Yes, it is free from the fraction power, because here the power is 4, here the power is 9. It means degree of differential equation exists. If degree of differential equation exists, what is the degree? 9 or 4? What is the degree? 9 or 4? I hope you should be able to tell me, or you have got till now what is the answer? degree is equal to 4. Why? Because we are looking for highest power of highest derivative term. So here this is the highest derivative term. So what is the highest power of second order derivative term? That is 4. So I can say degree of the given differential equation is 4. So I hope students it should be clear for all of you like how we are going to find out the order, how we can find out the degree. So order of differential equation is very easy to find out. Like we have to simply see whether what is the highest derivative term. So here only when I have given you this differential equation, here only I can find out the order. What is the order? Order of this differential equation is 2. But to find out the degree, we have to do some manipulation. We have to check whether it is polynomial in its derivative term. Then we have to check whether it is free from the fraction power, and then finally we will get the degree. But order is very simple to find out. By seeing the differential equation only, we can say the differential order of the differential equation is 2. And there is one more point, order of differential equation always exists. Order of differential equation always exists. Degree may or may not exist. Okay, I will take some examples from previous year CET problem, the CET exam, where there we will see like some problems are there or some differential equations are there where we can say different degree of differential equation does not exist. Okay, so before moving, I will just tell you the example. You can say, sir, can you give us any example where degree does not exist? Yes, we have the example. Now, suppose I am writing d square y upon dx square x is equal to exponential of dy upon dx. D square y upon dx square is equal to exponential of dy upon dx. Now I am asking, can you please tell me the order? First tell me the order. I hope everyone should be able to tell me the order. Order of this differential equation is 2. Simple. Highest power, highest order derivative is 2. So order of this differential equation is 2. Now, if I am saying to you, can you please tell me the degree? So don't say degree is 1. First we have to check whether it is free from the fraction power, whether it is polynomial in its derivative term. No. Why? Because if we will expand it, what is the expansion of exponential of x? So exponential of x expansion is given as 1 plus x square by factorial 2 plus x cube upon factorial 3 plus x power 4 upon factorial 4, and it is continue up to infinite. Okay, it means this power will be extending up to infinite, and we know that when power of x is infinite, or when alpha is a infinite number, then it will not be a polynomial. It means here we will get the dy upon dx power infinite, so that's why it is not a polynomial. And if it is not a polynomial in its derivative term, it means this is not a or degree of this differential equation does not exist. Okay, now there is one more thing. Suppose there is one more way to check it. Can I write like this? Dy upon dx is equal to log of d square y upon dx square. Can we write? Yes, we can write down. Okay, I am just taking logarithmic of both sides. So when I will take logarithmic of both sides, this will become log of d square y upon dx square. This will become dy upon dx. Now we already know if we will expand this one log x. What is the expansion of log x? This is also contains infinite number of terms. So now this will be having infinite number of terms. So since this is infinite number of terms, so we can say again degree of differential equation does not exist. I hope it should be clear for all of you under what is the condition for degree to exist, then what is the fraction power, how we can make it free from the fraction power, and after that how we can find out the degree. So now I am going to take the example from previous year CET problems based on order and degree of differential equation. Okay, so I'll take first problem. This is CET 2014, they have asked this problem. So CET 2014, they have asked this problem, like simply they have written y is equal to x dy upon dx plus 2 upon dy upon dx. This is the differential equation, and this problem they have asked in CET 2014. CET 2014 exam, they have asked this problem, and we have to find out the order and degree. I hope students, by seeing the problem itself, you will get to know what is the order. I hope everyone should be able to tell me what is the order, or you got it till now. Order is simply 1 because highest order derivative present in this differential equation is of first order. So we can simply say order of this differential equation is 1. Now we have to talk about the degree. Now first we have to check whether it is a polynomial in its derivative term. So you will say, sir, actually we can write down like y is equal to x dy upon dx plus 2 dy upon dx power minus 1. Okay, you will say, sir, this is not a polynomial in its derivative term because I have told you power is minus 1. Minus 1 is not a whole number. It means this is not a polynomial. But before that, we will check whether can we make it as a polynomial? Yes, we can make it as a polynomial. How? Can I write like this? I will just dy by dx, I will multiply. So this can be written as y dy upon dx is equal to x dy upon dx power 2 plus 2. Now the same differential equation we have write down in this format. Now if I am asking you, can we say this is polynomial in its derivative term? Yes, because here the power is 1, here the power is 2, 1 and 2 is a whole number. It means this is polynomial in its derivative term. Okay, after that it is free from the fraction power. Now what is the degree? Highest power of highest order derivative. This is highest order derivative, so highest power of this order, this is 2. So we can say degree of this differential equation is 2. Okay, order of this differential equation is 1 and degree of this differential equation is 2. I hope this is very simple to check. Okay, I have already told you to find out the order of differential equation is very simple by seeing the problem only within 1 second or less than 1 second. I'll say we can find out the order of differential equation. For finding the degree, we have to check all these conditions. Okay, so I hope it is clear for everyone. Now I will take another example. Yes, you will see on the screen what is the another example, order and degree. Now okay, so another example they have asked in CET 2016 and they have asked order and degree of differential equation. So this is the differential equation, 1 plus dy upon dx whole square plus sine dy upon dx power 3 by 4 is equal to d square y upon dx square. And this problem they have asked in CET 2016. Okay, so I hope the moment I have write down this differential equation, if I am asking you, can you please tell me the order? For everyone, this is very simple. By the moment I am writing the differential equation, at the same moment you should be able to tell me, sir, this is the order of this differential equation. I hope everyone got it. What is the order? Order of this differential equation is 2. I have told you order is very simple to find out for any differential equation. Here highest order derivative is 2, so we can say order of this differential equation is 2. Now next thing is we have to find out the degree. So to find out the degree of this differential equation, what I can do? Like first we have to check whether it is polynomial in its derivative term or not. So for that one, how we can do? Like we can say, sir, we can take the fourth power. Yes, we can take fourth power. So 1 plus dy upon dx square plus sine dy upon dx whole cube is equal to d square y upon dx square power 4. Now if I am asking you, can I say this is polynomial in its derivative term? So everyone will say, sir, yes, this is polynomial in its derivative term. So what is the degree? Highest power of highest order derivative. So highest order derivative is second order derivative. What is the highest power? 4. And the moment you will say 4, it means option B. So first, before that, you have to check whether, so you have to check everything. So whether exactly still it is polynomial. No. Why? Because if you will see this one, sine dy upon dx, I have already told you, if you know what is the sine z expansion, sine z expansion is given as z minus z cube upon factorial 3 plus z power 5 upon factorial 5 minus z power 7 upon factorial 7, and it is continue up to infinity. Again, if in place of z, if I will put dy by dx, it is having infinite number of derivative terms, and again the dy by dx power will be infinite. It means it is not a polynomial in its derivative term. Since this is not a polynomial in its derivative term, so what I can say, degree does not exist. Okay, so option D would be the correct option. Order will be 2, degree is not defined. Okay, so that's why in exam, before solving the problem, you have to take care of each and every condition. For order, there is no condition. By simply you have to you have to look at the differential equation given to you, and you will get to know that order will be 2. But when I'm talking about the degree, first you have to check again whether the differential equation is polynomial or not, and we have to check the polynomial only for the derivative terms. Okay, only for the derivative terms. Suppose if it would be sin x here, for example, if I am saying that sin x, then degree exists. Yes, degree exists. Why? Because it is polynomial in its derivative term. Here the power is 4, here the power is maximum power 2 power 3 is 6. So we are able to find out maximum power. It is polynomial in its derivative term. So we can say degree of this differential equation is 4. But here in place of x, we have dy by dx. And when I will expand it dy upon dx, it would be continue up to infinite. It is having infinite number of derivative term. It means the given differential equation is not polynomial in its derivative term. That's why degree of this differential equation does not exist. So option D is the correct option. Okay, next, CET 2017, they have asked this problem. Okay, and they are asking degree. If you have seen the problem, 1 plus dy upon dx whole square power, this is 1 plus dy upon dx square whole square is equal to d square y upon dx square. I hope you should be able to tell me the degree now. This is simple problem, CET 2017, last CET 2017, they have asked this problem. Okay, so what is the differential equation? 1 plus dy upon dx whole square is equal to d square y upon dx square. Now, I hope you should be able to tell me what is the, first tell me the order. Order is very simple. Order of this differential equation is 2, because highest order derivative is 2, so order of this differential equation is 2. Now we have to find out the degree. So what is the degree? Degree is, because we are looking for highest power of highest derivative term, so highest derivative term is this, and what is the highest power? Highest power of this highest derivative term is 1, so we can say degree is equal to 1. Okay, I hope it is clear for everyone. Okay, now I will make this problem bit interesting. I'm not saying that this is differential equation. I'm simply changing one term. 1 plus dy upon dx whole square is equal to dy dx. Now, I'm expecting you should be able to tell me the degree of this differential equation. So, what is the degree? Just tell me, like you can, I hope you should be able to get. Now the degree is 1, or just you have to see what is the degree. I'm giving you option, degree is 1, or it is 2, or it is 3, or it is 4. Okay, so degree of this differential equation would be 4, because here if first we will see what is the order now. Order is 1, highest order derivative is 1, first order, so we can say order of this differential equation is 1. So since order is 1, so we are looking for the highest power of highest order derivative. So highest power of highest derivative. So you will say, sir, this is 2. But if we will expand it, can we expand it? So when I will expand it, this is a plus b whole square. So a plus b whole square is a square. B square dy upon dx whole square power whole square. So this is 4 plus 2ab. 2a is 1, b is dy upon dx whole square is equal to dy dx. Yes, sir. This side? No, it is d square. No, I have changed the problem now. Yeah. So 1 plus dy upon dx power 4 plus 2 dy upon dx square is equal to dy dx. Okay, so now if I'm asking you, degree is equal to 4. Okay, I have slightly changed the problem, so that's why degree is 4. For the given problem, degree is 1 definitely, because this is highest order derivative term. So highest order derivative term, so that's why degree of this power, highest power of this derivative term is 1, so that's why degree is 1. But when I'm changing the differential equation, I have simply changed it dy upon dx, so we can say degree here is 4. Okay, why I have changed this problem? Because I want to show you, in this case if I'm writing, then don't say that degree is directly 2. Why? Because you will directly see, sir, highest power of this dy upon dx is 2, then we can say degree is 2. No, degree is 4. We have to check. If I will expand it, highest order derivative for this term is 4, that's why degree of this differential equation would be 4. Okay, now another problem. Like if you will see CET 2014, CET 2016, CET 2000, last problem they have asked in CET 2017, then CET 2018. So at alternative year you will get one problem based on order and degree of differential equation. So that's why I have already told you this topic is quite important for the CET exam. Okay, now so again we have to find out the degree and order of differential equation. So this is the degree and order. So d square y upon dx square is equal to, this is cube root 1 plus dy upon dx whole square. This is the differential equation. And CET 2018, they are asking order and degree of this differential equation. So again, like we can, I'm asking you what is the degree order. I hope the moment I'm ending the write down this problem, so you should be able to tell me what is the order. Order of this differential equation is 2, because we have already discussed many times, highest order derivative present in the differential equation gives me the order. So highest order derivative is second order derivative, so we can say degree of this differential equation is 2. Order of this differential equation is 2. Now we will talk about the degree. Okay, so if I'm talking about the degree, so first if we will talk about this one, so this can be written as d square y upon dx square is equal to 1 plus dy upon dx whole square. Okay, and this is cube root, so how I can write down, this is 1 by 3. Now it is polynomial in its derivative term. Till now it is not polynomial, because if you will see, what will be the power, 2 upon 3. But can we make it? Yes, we can make it. How? We can take the third power of both sides. So when I will take the third power of both sides, this can be written as d square y upon dx square whole cube is equal to 1 plus dy upon dx whole square. I hope everyone is fine. Like we have take third power of both sides, so this become d square y upon dx square power cube is equal to 1 plus dy upon dx square. Now if we will see, first condition we have to check whether it is polynomial in its derivative term. Yes, this is polynomial in its derivative term. How? Because here the power is 3, here the power is 2, and we know that 3 and 2 both are the whole number. It means it is a polynomial. Second condition, it is free from the fraction power. Yes, it is free from the fraction power. There is no fraction power. And then can we find out the degree? Yes. What is the degree? Degree is the highest power of highest order derivative term. So highest derivative term, what is the highest power? 3. So that's why I can say degree of this differential equation is 3. Okay, so order of this differential equation is 2, degree is 3. So we will take one last problem based on order and degree. Then okay, so might be this problem is not presenting on the screen. I am writing because CET 2000, I think CET 2019 they have asked that problem, so we will take that problem because that problem is also a bit interesting. So somewhere the problem was like this: we have d square y upon dx square, and I am taking this example because it is having one another concept which is very helpful for finding the degree. So this is d square y upon dx square, dy upon dx power 1 by 3 plus this is y power 1 by 4 is equal to x power 1 upon 5. This was the differential equation somewhere. Okay, exactly I'm not able to recall, but this was the differential equation somewhat. Okay, now CET 2018 or CET 2019, they have asked this problem. We have to find out the order and we have to find out the degree. Okay, so if I'm asking you, can you please tell me the degree? Yeah, sorry, first order. So I hope everyone will be able to tell me what is the order. Order of this differential equation is 2, because highest order derivative present in the differential equation gives me the order. Order we can say simply order is 2. Now we have to check the degree. Okay, so for finding the degree, what is the first condition? First condition number 1, it should be polynomial in its derivative term. So is it polynomial in its derivative term? No, this is not polynomial. Can we make it? Let's try. Okay, so can I write the given differential equation in this way? D square y upon dx square plus y power 1 upon 4 minus x power 1 upon 5 is equal to dy upon dx power 1 by 3. And when I'm taking into this side, this would be minus. Now, can I take the third power of both sides? So if I will take the third power of both sides, d square y upon dx square plus y power 1 by 4 minus x power 1 upon 5 whole cube is equal to minus of dy upon dx. Okay, third power of 1 by 3, it will give me first power, and minus means minus 1 cube. If I'm taking minus 1 cube, it will give me minus only. So minus will be there. Okay, now it is free. Now if I'm asking, it is polynomial in its derivative term? Yes, it is polynomial, because if you will see, what would be the power of d square y upon dx square? 3, then 2, then 1, and here the power is 1. This differential equation is, we can say, polynomial in its derivative term. Second condition, it is free from the fraction power, but we will not be able to make it free from the fraction power. Why? Because if we will take the cube, so we will get 3 by 4, 2 by 4. Here also we will get 3 by 5, 2 by 5. So it is polynomial in its derivative term, but we are not able to make it free from the fraction power. That's why we can say degree of this differential equation does not exist. This was the point, students. Like if you have checked, if you will see, like this differential equation is polynomial in its derivative term, but still degree does not exist. Why? Because I have told you, first we have to check polynomial for the derivative term, and then second we have to check whether it is free from the fraction power or not. So here if you will see, we cannot make it free from the fraction power. That's why I can say this degree of this differential equation does not exist. Sir, done. Yes. Yeah.
It's very good, Pankaj.
Yeah. Thank you, sir.